Okay, so let's get started with the definitions. Acids are a special type of chemical, and basically they're ones that release H plus in aqueous solutions. We got an example right here. I'll tell you guys the parts that you guys need to write down, but HCl is an example of an acid. If you put it in water, it breaks up into H plus and Cl minus, which means it releases H plus, right? So a short definition for an acid is an H plus donor. It gives away H plus. So write that part down. Okay. Acids are H plus donors. Basically, when you put them in water, they give H plus to different chemicals.
Sure,
you're an acid. Okay. The next type of compound is a base. And bases are a little bit trickier because you can have two definitions for it, and you're going to want to write both of them. The first definition is that they release OH minus in aqueous solution. So they give Me away. Okay, so you put NaOH inside water, they break up into Na plus and OH minus. Okay, so they give OH minus away. The other definition of a base is that they accept H plus from other compounds. Okay, so that's another way that you can define it. Okay, so acids are easy. They give away H plus. Base is a little bit trickier. They either release OH minus or they accept H plus. Okay, so that's all the definitions basically for the unit. We're just going to be applying this in different situations now. Okay. All right, so we're going to look at some different types of chemical equations. I'm going to show you guys how you can identify the acid and the base in the equation. The thing about acids and bases is that you have to have them together. You can't just have them by themselves. Okay, they work together with a different compound. So let's take a look at number one. Now, you guys don't need to draw the picture, but I want you guys to write this equation right here. Okay, don't draw the picture. It's kind of just there for us to visualize. But take a second to write this equation down. Okay, we're going to be identifying which chemical is the acid and which chemical is the base. So take a minute to copy down this equation, and I'll show you guys how to identify that. Okay, so in order to identify the acid and base, obviously you guys need to remember the definition for acids and bases. So let's look at the acid first. I think that makes it the easiest. So an acid is going to be an H plus donor, which means that it gives an H plus to the other chemical. Now, let's take a look at the two chemicals we start with. We start with HCl, which is right here, and we have H2O. Okay, now we're basically just trying to figure out which one of these gives H to the other chemical. Okay, so if you guys take a look at it, take a look at the red hydrogen right here. That's the one that's going to be moving. If you guys notice, as we go from on the left side, H is connected to which element?
Cl.
Yeah, it's connected to Cl. That's how we start. But if you take a look on the right side of the equation, is that H still connected to Cl? No, right? Now it's connected to the oxygen. So what you can identify here is that this hydrogen right here came from HCl and it attached to the oxygen inside of water, which made H3O plus right here. Okay, so between these two chemicals, which one is the one that lost or gave away the hydrogen? Yeah, HCl. So this right here is going to be your acid because it gives away a hydrogen. This guy received the hydrogen, so this guy will be your base. So water is your base in this situation, okay? So that's what you want to identify. Just need to identify who loses a hydrogen and who gains a hydrogen, okay? And that's pretty much what you'll be doing today. It's not too bad, hopefully. All right, you guys think you could try one on your own? Yeah? Okay, well, regardless, you guys can try one on your own. Okay, so take a look at this. You guys don't need to draw the pictures. I just gave you the picture, but I want you guys to write the chemical formula for the one that you think is the acid and which one you think is the base. I'll give you guys about a minute to do that, and then we'll go over it together. Okay, so if you guys take a look at this equation right here, if you notice, hydrogen again was originally attached to the chlorine, right? But after they react together, hydrogen is now connected to the nitrogen. So you should be able to see that this hydrogen right here moved from the chlorine to this compound right here and attached there. Do you guys see that? How it moved from here and attached to the nitrogen. So this one is the one that gave away the hydrogen. So the chemical formula for your acid is HCl, and this chemical received a hydrogen. So this is your base, which will be NH3. Okay. So that's going to be how you can identify those two. All right. So I've been told that this is a little too easy. So we'll make it a little bit more challenging now. No, there's one person that said that. Sits in front of you. Okay, so now we're going to be talking about conjugates. But before we do that, take a look at this equation. I want you guys to write this equation down. And same thing, I want you guys to identify the acid and the base. We'll talk about what the conjugate in just a second. You can probably see the definition right here, but we'll go over that in a second. So I want you guys to write this equation, and I want you guys, same thing, identify which one's the acid, which one's the base, and then we'll talk about how to find what a conjugate is. Okay, so very simple. You guys should have been able to identify here that NH3 receives an extra hydrogen, right? Because it turns from NH3 to NH4. So in this process, it gains a hydrogen. Do you guys see that?
Yeah.
NH3 becomes NH4. You add a hydrogen to it. So that means NH3 gained a hydrogen. So since it gained a hydrogen, what do we call chemicals that gain hydrogen?
Bases.
Yeah, base. Yeah, bases gain hydrogens. All right. All right, let's go to the other one. So since this is the base, obviously it needs to receive a hydrogen from the other one. So this guy's going to be your acid. Okay, and you might be able to tell that this turns from H2O to OH minus. So if you guys take a look at it, OH minus is the same thing as H2O, except you just take away one of the hydrogens. Okay, right? If you take one of the hydrogens, it's HO, but we don't like that word, so we flip it to OH. Okay. All right, so here the acid was H2O and it lost a hydrogen. Okay. Now let me give you guys a quick trick that might be helpful this unit. I know you guys learned the chemical formula for water as H2O, right? But a lot of times it might be easier to kind of think of it as this HOH. Okay, because a lot of times water can act as an acid, so it could lose a hydrogen. And so it's kind of easier to visualize it like this than trying to take away this and then flipping it and whatnot. So if this is a little bit more helpful, whenever you see H2O, you can always just change it to HOH. And I like this one because it kind of looks like a funny face. Okay. All right. So that's acids and bases. Now let's talk about what the conjugate and the conjugate acid and the conjugate base is. So if you guys notice, this base gained a hydrogen, right? So that means on the other side of the equation, what happens is since it gained a hydrogen, this guy's also able to give away a hydrogen. So whatever the base turns into, we can call that the conjugate acid. Okay. So whatever chemical the base turns into, we call that the conjugate acid. Okay. And then whatever chemical the acid turns into, since it lost a hydrogen, right, it could still potentially gain one now. We call this the conjugate base. Okay. So if you want a very easy way to think about it, the acid turns into the conjugate base, and then the base turns into the conjugate acid. Okay, so basically it just turns into the opposite when it becomes conjugate. All right, any questions about that, or does that make sense? Okay. All right. And just to show you guys how easy it is to figure out what the conjugate acid and the base is, we're going to do 8 problems, and we're going to go through them real quick. It should take like 10 seconds each to do. I'm going to show you how to do one of them, and then you guys can try the other one, okay? You guys ready? Okay, so when an acid turns into a conjugate base, all you got to do is take away a hydrogen from the acid. So numbers 4, 5, 6, and 7, these guys are all acids, okay? And all we're going to be doing is we're going to remove a hydrogen from the acid, and that's going to be your conjugate base. So this chemical right here is an acid. So if I want to turn it into my conjugate base, you just take away a hydrogen. So if you take away a hydrogen, you get ClO4, but it's H plus, so it's just going to be, it's going to turn a little bit negative. And this right here is your conjugate base. Super easy. Okay, all you got to do is take away a hydrogen and just put a negative sign. It just becomes one more negative. All right, so I'm going to give you guys, this should be really easy. I'll give you guys a minute to try the next three. You guys don't need to copy down like acid, conjugate base. I just want you guys to write the formula. Check it with the person next to you. The only thing I'll tell you guys to be careful of are the charges. For example, this one is +1. This guy is -1. So think about, just make sure you're careful what happens when you take away H plus, okay? So I'll give you guys a minute to do that, and then we'll go over it together. Too bad? All right, so if you take a look at H2S, if I take away a hydrogen, what's the formula? Yeah, HS. And a hydrogen is +1. So if you take away +1, this guy is neutral, right? It's 0. So if you take away a positive from 0, what's the charge? Negative, yeah, -1. So it's HS minus. Yeah, he told you. Come on, man. All right, next one. You got pH4 plus. So if you take away a hydrogen, what's the formula? Yeah, pH3, because you take away hydrogen. This one is +1. So if you go one negative from +1, what's the charge? 0. So this guy is neutral. Yeah, because it's +1, right? If you have a number scale, +1, you drop down 1, it's 0. You drop down from 0, it's -1, so on and so forth. Okay. All right. Last one right here. You got HCO3 minus. Hopefully you can tell the formula is going to be CO3. Now, this guy was -1. So if you drop down from -1, what's the charge? Yeah, -2. So it's 2 minus. There you go. Yeah. So the hardest part here should be just keeping track of like where you are, how you're going to move down the charges. But when you go from acid to conjugate base, you just need to do -1. Okay. All right. Let's go on to the next four. The next four is about the conjugate acids and the bases. So if you guys take a look at this, all these chemicals are bases, okay? And what we're going to be doing is we're going to be figuring out the conjugate acid. Now, this is going to be the exact opposite of what we just did for the acids and conjugate bases, okay? So here, instead of taking away a hydrogen, you're going to add a hydrogen. So the formula is really easy. If I have CN, I just add a hydrogen. Usually we add it to the front. So HCN, that's it. And if you guys notice, this guy was -1. If you add 1 to -1, you move up to 0. So this guy is neutral, so you can just leave it at HCN. Okay, so if you guys just want to write a number scale on the side of your paper, just so you can kind of see how the numbers will move, that might be helpful. But here, we're going to be going up the scale because we're gaining H plus. Okay? All right. I'll give you guys a minute and a half to try 9, 10, 11. We'll go over it together, and then we'll do one final problem, just putting everything together, and I'll get you guys started on your assignment. All right. So we got SO4 2 minus. We're going to find the conjugate acid, so we have to add a hydrogen. So if I add hydrogen, just put an H in the front, HSO4. Now, if I add a hydrogen, what does the charge become? If it was -2, it goes up 1 to -1. So there'll be HSO4 minus because it needs to go up the number scale. All right, let's go to the next one. You got H2O. If you add a hydrogen, it becomes H3O. And since it was neutral, it was at 0. If I go up from 0, that's +1. So H3O plus. Okay, last one right here. We got HCO3 minus. If you add a hydrogen, it's H2CO3. And since it was -1, we go up the scale to 0. So this guy's neutral, and you can leave it alone like that. All right. So if you guys are still getting the charges wrong, it's okay. That's why we're going to be practicing. This is the trickiest part, just keeping track of the charges on the top right. But just make sure that you guys really understand the adding the hydrogen and taking away the hydrogen, because that'll be a little bit more important than the charge. But make sure you get the charge down too eventually. All right. Any questions? Okay, let's do the last problem together, or I'll have you guys try the last one on your own. and then we'll be done. So this is your equation. I want us to jot this down, and I want you guys to identify the acid, the base, the conjugate acid, and the conjugate base. Okay, if you guys forgot the definitions, go back in your notes to just review them real quick. I'll give you guys about 2 minutes to do that, and then we will double check because this is what you'll be doing for your assignments today. Okay, so hopefully you guys were able to see that the hydrogen right here, or HNO2 right here loses a hydrogen. So this guy loses hydrogen. And if I lose a hydrogen, what type of chemical is this? Yeah, this is an acid. And since this is your acid, this is going to be your conjugate base. Okay. Now this compound right here, H2O, if you guys notice, turns into H3O plus, which means it gains a hydrogen. And if you gain a hydrogen, what type of chemical are you? Base. And so this guy turns into a conjugate acid. Okay. All right. So hopefully you guys were able to get that. If you mixed up one or two of them, that's not too big of a deal, but just make sure you understand the general idea. I'll let you guys get started on your assignment. And let me know if you guys have any questions. All right. Good luck, guys.